Okay, now if you're watching all these videos in order, you just heard me ramble on a little bit about the last problem, which I've already filed away, how it could be a problem involving like kicking a soccer ball. Here's why I was talking about that. I'm doing page 328, number 11. We're talking about physics, all right? This problem is a little different than the other problem because the function I was talking about uses time as its independent variable. So it's how high the ball is when you got a stopwatch on it. This one's going to be a little bit different, but the idea is very similar. They are very much related. Okay? And hopefully one day when you guys are in your physics class that you'll be like, I know how to do this. So hopefully by getting you ready for Algebra 2, you're getting ready for physics. That's what my hope is. All right, let's read this problem. The path of a soccer ball is modeled by this function. H of x equals negative 0.005 x squared plus 0.25x. So let's write this. The height at x is negative 0.005 x squared plus 0.25x. Now, I mentioned in class and I mentioned in the previous video that this number right here has to do with the coefficient of gravity. I'm sorry, I got the hiccups. Take a deep breath. Coefficient of gravity. That's true if you're using time. But this one, the x is going to be the horizontal distance that the ball travels. So, I don't know what this graph is going to look like exactly, but here's my idea. Okay? So this is going to be x. This is how far horizontally it's going to travel. And I'm going to kick the ball, and it's going to make a parabola. It's not a very good parabola, but that's okay. All right? So the height is based upon how far I've kicked it. So there's a couple of other vectors in there. Time is also there, but that would be a different function. So I don't really... This is where I don't want to spend too much time talking about the physics of it. All right? So I just want to draw attention to the fact that that is not the negative 16 in feet per second squared or the negative 9.8 meters per second squared. It's going to be the it's a coefficient based upon the distance going this way. All right? And this way is going to be the height. Okay, cool. All right, we got that. We want to find out the maximum. Everything else is going to work there. So how high is this soccer ball going to go? All right? First, I have a maximum because, well, first of all, it's going to say what's the maximum height. But I have a maximum because this is negative, which makes it an upside down or opening downwards frowny face parabola, which makes sense because gravity is going to go up, it's going to come back down. All right, cool. I know there's a maximum. Let's find out what that vertex is. My A is negative 0.005, and my B is 0.25. My C is 0. That is not going to change anything except for the fact that that just means that when the horizontal distance is 0, the height is 0. In other words, the ball's on the ground. That's all that means. First of all, let's find the axis of symmetry. This is b over negative 2a. So this is 0.25 over negative 2 times negative 0.005. Calculator time. Yep. You always have to multiply first, but I'm going to do that in parentheses, so it's okay. So 0.25 divided by negative 2 times negative 0.005 parentheses. I don't know if you can see that. I'll move it right there. 25. All right. What does that mean? That means that x equals 25. So if I draw my graph, I'm going to draw a dashed line here. This is at 25. Now, here's a couple of cool things about it. It's not in the problem, but here's what's cool about it too. This has symmetry. So if you kick a ball and it follows this path, if it starts at 0 at x equals 0 and the maximum is x equals 25, it's going to land 50, are we in feet? Meters. 50 meters away. That's a pretty decent kick. 50 meters. Must be Minnesota United here. All right? The 50 just means you went up to and you came back down, because these are symmetrical. It's 25 from here to here and 25 from here to here. Okay, but that wasn't really part of what we're asking for. It's just good stuff to talk about. Now I need to find the height. So I'm going to do h of 25 equals negative 0.005 times 25 squared plus 0.25 times 25. Sorry. All right. Negative 0.005 times 25 squared plus 0.25 times 25. That tells me that the height at the maximum is 3.125 meters. Now, those of you who are already in chemistry, or some of you may even be in physics, are going to realize that I'm not using proper significant figures. Okay? I'm just doing the math part of it. You cannot have a measurement that's actually more accurate than you started. And since I don't have any basis on where I started, I don't know what that accuracy would be. So we're just going to go with the 3.125. All right, so don't panic about that. That the significant figures does come up. And if you're sitting there going, what the heck are significant figures? Let it go. It'll be okay. So what that means is that this height right here is a little bit more than 3 meters. And 3 meters, if you are an American, a meter is about 3.2 feet. So if I multiply by about 3.2, it's about 10 feet, which is not bad. 10 feet is where the top of a basketball net would be. Okay, to give a point of view, all right? Not that you're kicking a soccer field on a basketball net. All right, good luck.